So, hello again. So we want to do some new stuff. Let's try LVM, Logical Volume Manager. Let's install Debian13 Trixie on LVM, Logical Volume Management. And we create 3 small disks and install their Debian with LVM. So the virtual machine is already working. Here we are in the Debian menu for the Debian install. And I show you before the setup. I created 3 qemu images. This is virtual disk image. This is also what is happening in the background when you do virtualization with virtual machine or virtual manager also. And I do this all in the terminal, yeah. And I show you this are images, and I set the size of the images to 3 GB of each one. So here I have a script, a bash script, qemu LVM for disk, and I show you how I start the virtual machine. Just some stuff before. If waiver, I'm working on Debian on my host machine with Sway, the Wayland compositor Sway. This is very similar to i3 on X11, but more improved. And first I hide the waybar, then I start in the background delayed autofocus the VM, then I start the VM. So if I start the VM, it's getting autofocused. And afterwards I focus back to the Tmax terminal. And in the focus script, I work with commands from Sway to focus specific programs. So this is a specific command from qemu to start the virtual machine. This is the main command for the x86 and the 64 machines. And here is enable kvm, is enable the kernel virtual machine module to make the virtual machine faster. CPU host means use the host CPU, also makes the virtual machine faster than SMP. I give here the specific count of how many cores CPUs I want to use. Normally I work with 2, but in this case we start with 4. And -m is memory, 4 GB memory. And then here's display options. Display is GTK. This means give me a GTK window, a real window with the machine. I can also start qemu in the background without a window and log in with SSH if I set up this. Window close off is good to make sure that you don't make the mistake and close the window. Show menu bar off is just hide the menu bar in qemu window. I can show you with Ctrl Alt M, you can show the menu bar, this one, okay. And zoom to fit is great, so important, but it's not per default with qemu when you start it from the terminal. This is very great because virtual machine is always zoomed to fit in. For example, I make this way to a floating window in Sway, and then I resize the window, and you see the real virtual machine is always fitting to the maximum of the window, okay. And if I do it complete, this is this one. This is not per default if you start qemu from the terminal. So this option is amazing. And then there are also some other stuff: show cursor off, show tabs off, grab on hover off. Spice disable is not important yet. And here, this is now the important stuff. Here I give the specific disk images. -HDA gives the first disk, virtual disk, qemu image, HDB the second, and HDD the third. And now you will be surprised why is not HDC there. I explain it in a second. Then I give -CD-ROM. This is an installation image, the Debian DVD ISO. This is a link in this case to the real ISO. And all the files are in the current folder. So with -boot, once equal D, I say please boot from the first disk, CD-ROM disk. D is for start from the first CD-ROM disk. And you can also use C. This would be starting from the first hard disk. So, and once means start at one time from this, and afterwards start the default way. So it's starting the first time from the disk, and afterwards, after rebooting, it's starting from the hard disk. This is also the case per default normally, but I give this specifically in this case this time. If the system is installed on the HDA, then it's starting from the HDA if you don't give any boot stuff. But if there isn't a system, you have to give specifically that he is starting from the CD-ROM. So normally I do the -boot D only, but the once equal option I found out just in this case. This is very, very good. So this is just the setup, and then I start the script, so I don't have to type all this time the stuff again and again. I have a complete pre-configured setup in a script, and if I want to make changes, I have to make it in the script, and then I can start it automatically. So I have only to make sure that the files are really in the folder, and then everything is fine. This is also good to make sure that you don't make any mistake with qemu images when you work with 3 virtual disks in this case. Okay. So because we want to create a LVM, Logical Volume Manager. So now I say some stuff about LVM later, but I will not make a complete introduction into LVM. But LVM is amazing, so we just try some stuff out. Normally I will execute the script with bash, and the script, important is the permissions must be given the X. You can do this with the command change mod, chmod, and then +X, and then it gives the script name, and then to make it executable. This is important if you work with the script. So I will also make videos in the future about the virtual machine or virtual manager, but I use it not that often. So the machine is running, we switch back, and let's do a graphical install. I make this in this case the simple way. And you know, it seems the machine is not running, and you know why? Because I have, normally it is running. Here now, it's needed some time. So let's do English, United States, American English. And then I'm really interested. I didn't do this before. So this is the first trial. We will see. The first trial was LVM, okay? I am going more into this stuff with working on LVM, and it seems very, very interesting. Let's do deb LVM, hostname, and root. Here is great, just by the way. Read the text, what is showing up here in the installer, and there you see in the text some account needs to be available with administrative super user privileges. The password for that account should be something that cannot be guessed. To allow direct password-based access via the root account, you can set the password for that account here. You can, you don't have to. Alternatively, you can lock the root account's password by leaving this setting empty. So this is important, which many people don't know. And I think I use Debian now 20 years, and I don't know when they inserted this, but I discovered this very late, that you can leave the root password empty, so the root account will be locked. And this is recommended for more security, because you have many, many more options to recover your system. When something got broken, you can enter your system. This is also possible. So, but for example, security related stuff. The first point when people try to hack a system is to get to go into the root account, and if the root account is disabled, then this option is not there for hacking. So it's more security. Okay, this is important. So I leave this empty, but read the text, and then okay. Just by the way, I try to remember this all the time in the future because many people don't know this. So let's leave it empty. The name, because the user, the first user. So make sure you make a secure password in real installations. I make it very short for some stuff here. Also important to learn about secure passwords. There is a in Linux you can use. There is in the terminal, you know, or I don't know. There was a program you can install to put out secure passwords, to create secure passwords in the terminal. Password generate or gen password or anything. So I'm going to talk too much again. I'm already learning. So now we are in the installation point here, partitioning. And now we could use the complete disk, and we could use the complete disk with a logical volume setup, and we could use LVM with encrypted. But this is only for default setups, and we want to make a specific case, so we don't use this options. We do it manual way. Okay, if you only have one disk, you can just use the setup with LVM. The normal or encrypted way. And LVM, when you know this, you learn LVM is amazing because you can add later more space to your system, which is not possible with a normal installation. Okay, so this is just the first video about LVM, what I do. And now we see here, I will make more stuff in the future, I think so. So now we see here the 3 disks. 3.2 gigabyte qemu hard disk, and they are empty. Okay. So we enter here, create new empty partition. Oh no, that's not what I wanted. Let's start qemu again. Qemu is just a time tracker script. And create new empty partition table. Yes. Now we have free space. So let's create first all empty partition table. In this case, Debian is using in the normal installation the old MS-DOS MBR, the old partition table format, and not GPT. If you want to use GPT partition table, you have to execute the expert install, which is not that expert that you have to be scary. You get more options, and you can specifically define which partition label you want and so on. I will show this in the future, I think so. So here we do it with a normal old MS-DOS partition way. We created a partition table on each disk of the 3, and now enter the first, create a new partition, and we use not the whole size. This is the first disk. So on the first disk we want to create a boot partition, and we don't set the boot partition in the LogicalVolumeManager. We set it before. So let's do 709 MB for boot. Primary, beginning, use, we let this, and the mount point is boot. Defaults, blah blah blah. Done settings. So now we have the boot defined, 700 megabyte. On the real disk, you can use 1 gigabyte is good, 500 is too less. So, and I choose to go for 700 megabytes for the most times. Yeah, for the boot partition. It depends. On Debian, you can normally also go with 500 megabyte, I think so, but 700 is more secure. And I have the case with another system where more stuff got installed in the boot, or the kernel was a bit bigger or so, and then you could get in trouble. So 700 or no more secure is 1 gigabyte for boot. So let's do this, create a new partition on the other stuff. And now I think we go primary here, and then we go physical volume for LVM. Okay, this is what we do. Here's also rate. Physical volume for encryption would be for encryption. We make just a simple LVM setup in this case. Physical volume for LVM. Done. So now you see there is K and LVM. So this is in this moment or everything. We set up the physical volume. And then let's do it the same here, create partition. Here we use the full size, primary, and then physical volume for LVM again. And then done. The same for the second. Now the third, create partition, whole size, primary, and then again physical volume for LVM. So done setting. Mark these words, physical volume for LVM, PV. Okay, there are more stuff I show you. So now we have the boot partition, then we have LVM, 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 and now we want to combine these 3 disks to use this as one big disk. Okay, and this is what we now in the next step do, configure the logical volume manager. Okay, but first I want to show, okay, important here, I forgot this. You know, I have shown you my script. Here the HDA disk, the HDB disk, and then the HDD disk, and then the CD-ROM. Why I don't use HDC? Because you cannot use HDC and CD-ROM in the same time. I learned today. I had this mistake before again and again, and I had to find the solution, and now I know the solution. So if you use this case that you start qemu from the terminal and you want to work with multiple qemu images, you make sure, I think the limit for IDE drives on qemu is 4. So this is 1, 2, 3, 4 with the CD-ROM, you know, and you cannot use HDC and CD-ROM at the same time. This was the solution. Okay, there is an option to use specific. Here's a. You can give drives with file. There are more options to give more disks and devices to qemu, and there is some stuff with giving the IF equal virt.io with virtual IO. But I just named by the way. So, but in the normal way, it's limited to 4 IDE devices. Okay. So, and we read here in the manual page, use file as CD-ROM image. You cannot use HDC and CD-ROM at the same time. Yeah. Okay. I hope this was helpful. By the way, this was the main problem in creating this scenario. I lost a few hours to get to the solution. So, LVM. I want to show you, I have not planned this. Let's take images. Let's do this. Oh no, this is chap. I should prepare this in the next time. But no. here. Okay, here. You see here the overview about LVM. You can read it by yourself. So here is exactly the case I have here. Dev SDA, Dev SDB, Dev SDC, 3 disks like I have given. So on the next layer, partitions, now we created here the boot partition and then the LVM. On the other disk, we created only one partition and gives this for LVM. And then the next, here, this is the layer we have done in this moment. We set it up as a PV, physical volume. And in the next step, we concatenate or bind together all the physical volumes to one volume group. Okay? This is what now will happen with the configuration. And then we go on the next layer where we set specific logical volumes in the volume group. Okay? And then we are more flexible in using the space. Yeah? So if you use LVM, learn the things. PV, VG, LV. Physical volume, volume group, and logical volume. This is important to learn and to understand in the layers. So just to show you, and now we are here, /boot, and here LVM, LVM, LVM. Okay, and now we go configure the logical volume manager. And now we see SDA, SDB, SDC, write the changes to the disks and configure LVM. Yes. So before do this configuration, he is writing the pre-configured stuff we have done until now. And now we configure the LVM. First, we go into the details and we see these are the details. The first is smaller because the boot partition is set before and the boot partition is not involved in the LVM. And the other are to the real size of the disk. So, create volume group, This is now what we do, the red one, volume group here. So, volume group, how to name it? Let's name it Deb LVM, like the host system, or let's Deb VG, Deb volume group. Okay, the group is combining the physical volumes. And what we want to add in the group, this is the SDA1, is the boot partition. We don't want to integrate this in the LVM. We use the SDA2, the SDB1, and the SDC1. Okay, this is what we use. And this we bind together in the volume group. And let's look the details. And now we see Deb VG, Deb volume group. This is the whole size now. So, and now you see we have in the beginning 3 small disks with 3 gigabytes only. And now we bring them together in a volume group and we get 8,942 megabytes. So nearly 9 gigabytes we get now. Okay. This is what happens. And now we have created the volume group. And now we can create logical volume. This is the third step. Okay, first we had the 3 disks. Then we created the physical volumes. And then we bind them together, or bring them together in the volume group. And now we create here the logical volume. This is now the step, what we create. So we create the logical volume like in the normal way we would create partitions. This is this in this case. And then afterwards we create the file system in the logical volume group like you would create a file system on a normal partition. Okay? So, and here we are. This is the details. This is create volume group, the step we had finished. And then create logical volume is what we want to do now. Also, you can delete a volume group, extend a volume group, or reduce a volume group. This is also very helpful. Maybe you can use the Debian installer also for use this. or you had pre-installed or pre-configured a disk with LVM, then you could extend a volume group or reduce a volume group. So, but we create now the logical volume. Okay, I will also create videos, I think, about doing this all manually in the terminal. But now let's create logical volume. And now you see the 9 GB dep volume group. We choose this volume group. And now let's name the first logical volume. And we name it, let's name it swap LV. And we give swap, let's do 342 megabyte swap. I make it very small. And the configuration details. And now you see swap LV logical volume is here. Okay, this was the first one. Now let's create the second, create logical volume. This is a volume group we want to use, and we name it, let's name it home logical volume, home LV. And which size we give? Let's give 1300 megabyte for the home partition, where the user directories are. And now the details we see swap LV, home LV, and then let's go for the third one, create logical volume, dep volume group, and now we say root logical volume. You can also name it LV-root. It's also possible. Do it how you like it. Root logical volume, and the size is 7300 megabyte. So now it's possible we could also do this a bit smaller and create a separate var partition, a separate temp partition, a separate USR partition. We could also do all the stuff, but I don't do this in this moment. So we just stay and use the rest for the root partition. Also, I have to say this is clearly, this is example only in a virtual machine, and it's very small. It's all very small. Yeah? This is a partition case for a small virtual machine. Okay, on a real hard machine, I would partition this much bigger. Okay, just to show you, it's optimized for virtual machine. Now we have swap LV 340 megabyte, root LV 7300 megabyte, home LV 1300 megabyte. Okay, so we have the volume group, and in the volume groups we inserted this 3 physical volumes, PV, VG, and then LV, and then inside them we have the logical volumes, like the real partitions in a normal. Okay, PV, VG, LV, physical volume, volume group, logical volume. Okay, I hope this is clear. And now let's finish this step. Continue. And now we get the overview, and let's look up. So really, a few years before it would be confusing for me, but now let's go through the steps. We have here the hard disk. We have the hard disk. We have the hard disk with the boot partition, and then the logical volume manager. This is a physical volume. Set up as physical volume. And then we have configured the logical volume manager, and then here's the other details of the logical volume. And now we have the volume here, LVM, VG volume group. The volume group is dep volume group, and then LV is the logical volume home LV. So here is the logical volume root LV, and here's the logical volume swap. And here we have the size for home, the size for root, and the size for swap. And now we have to define the mount point. So let's start with swap. Use as swap area. Done. And now you see, before it was empty, now we have swap. Then here, this is logical volume root. Use as ext4 journal file system. And mount point root file system. Done setting. Okay. Important is ext4 is a file system and the mount point. Done. Now we see ext4 and / the root mount point. Now the logical volume home. Use as ext4 mount point home. ext4 home at the end. So also you can page up, page down. You can position 1 and end to jump in the installer. It's faster than only arrows. The arrow. So now we have set up everything. Here are the hard drives and set the boot partition. Here set the physical volume. Yeah, these 3 are the physical volume. This layer. And then the logical volume is, and the volume group and the logical volume is this. The logical volume as a volume group and the logical volumes. And now in the last step, we created now the file systems ext3 or ZFS, and I used ext4 and swap. Okay, this is the last layer we have done now. So, and this is this one. The home, root, and swap, and here's the boot. Okay, so we are finished. We are ready. Let's continue. Write changes to disk. This is, we can check this. So now we just do a simple installation, installing the base system. And now, what can I say? I think, what do we want to install? I don't know. Directly a desktop or in a minimal install. I think we do a minimal install. It's a bit faster. So the other stuff is just the normal installation, but I will show you at the end the full system and how it looks with the graphical disk overview, to show you all the LVM stuff in the end result. So we do the normal installation, and I think we make a minimal installation. Afterwards we install Mate Desktop also. I don't have used Mate for a long time. So scan installation media. No, not more media. Use the network mirror. In this case I don't use network mirror because I run it from a DVD and I have all the desktops and main installation on the DVD. It's faster from the DVD. So let's just do this step. Participate in the package usage. No. And then we don't use GNOME, and now use Mate. You know, I think we just use the complete Mate desktop. In this case, it's okay. So 1,000 packages. This is not that much. And you see from the DVD, it's downloading it now, all the packages from the DVD in the installation image. And we will be very fast. So normally I also could do a minimal install without a desktop, and then I would install in the terminal sudo apt install, I would install, I don't know the exact package in this case, I think the Mate desktop environment core also. I would use this, install this, and I would install LightDM or check is LightDM installed, and then enabling LightDM, and then we also would have a Mate desktop. But in this case, from the DVD, it's very fast. So I will also make a video in the future about downloading the Debian DVD with the Jigdo download way. This is very interesting because you can easily update your Debian DVD. And you will not download all stuff again, only the changed packages. This is really amazing. And also you can download all the 22 or how many disks there are. Normally, for the normal download, you only get the first DVD with all the desktops. But with Debian, is it possible to get all packages from the mirrors on 22 disks or so, and you can install Debian complete offline. This is really, really amazing and helpful in countries where you don't have that good internet. So also using apt CD-ROM, and so these are things I could bring up in new videos. Very interesting. So let's run the installation. Let's look again here. So this picture is from Bildung.com. You know, let's go on the real page. I know this Bildung blog here. This is very helpful. They have good stuff in. Concept of LVM. Sample LVM setup. Yeah, this is only with one disk, for example. There are many possibilities with LVM. So you can also install a system on a LVM partition on a single disk like this one, and just use the system. But what is possible is, if you run out of disk space, you can add a second disk and then extend your logical volume. Then you would add the second disk as a physical volume to the volume group here, and then you would extend your volume group, and could also extend, I think, the home partition or the root partition or what you want. So the possibilities with LVM are amazing, and I'm just beginning to figure this out. Yeah, you can also remove one logical volume before you make sure to back up all your data, and also you, in the last step before you move the data out from the target logical volume you want to remove, there are specific commands. So there are really specific commands and how to work with logical volumes. There's a big flexibility to change things and so on. So because important is here also, if you have 3 disks, and a disk is, for example, one disk, the health of a disk is getting worse, you have to change the disk. So this means you have to change the logical volume and move all the data. So the one disk is ready to get free, and then get the disk out, then insert a new disk and add the disk again as physical volume. Here we are. Delete one disk. Yeah, you move all the data on the logical volumes on the others. Or first you add another disk and then have enough space, move all the data, then move all the data from the removing disk out, and then remove it as a logical volume out of the group, and then then you can run further, or add a new disk afterwards. It depends on which way you want to go. So here we are, group boot installer, and we install the boot grub on dev SDA on the first disk. Oh crap. Finishing the installation. So let's look up. This is the script. So I have said this HDC is not possible with CD-ROM at the same time. So this is a specific case. Also possible would be with virtual machine. So we are completed. Let's reboot. And now you see it is working well. It is starting from the new system. And you know, this was the boot once equal D option. Yeah, is booting in the first case from the DVD, from the CD-ROM DVD, and then after the installation, it's automatically starting from the real system. So, and now I'm really interested about the result. System is starting, and now you see this is light DM. Here we have the Mate desktop. This looks good. Then let's log in. I like this. And then here we are. This is the Mate desktop. So first, let's check the displays. Apply. Keep. Close. Now this is looking better. Here we have the DVD. And we have the preferences. And Synaptic is also installed. Accessories, graphics, internet, office, sound and video, system tools. So let's open a terminal. This looks good. And let's show the disks. So, and we see here, I hope this is big enough. The root file system. Here we have dev mapper. Here you see deb vg volume group and the logical volume root LV. Here we see dev mapper, deb volume group, logical volume home. Okay, so the main system. 63 GB used, real size 6.7, used 3.9, available 2.4. The home partition 1.2 is the size, used nearly nothing, available 1.1. So free-m, then you see here the swap, 300 megabyte swap. This is a virtual machine case, okay? And also we see the boot partition, 650 megabyte, used 90, only one kernel, and 500 free available. And this is a normal device name, SDC in this case. I don't know why sometimes he's changing the device names, SDC, SDA. I noticed this in some cases. I'm not sure about it in this moment. But okay. So this is this, then sudo fdisk-l. And now the output of fdisk. Fdisk, you see, dev SDB, the real disk, 3 GB. Dev SDC, 3 GB. And dev SDA, 3 GB. Okay? And these three disks we bind together with LVM. So here you see SDB1, Linux LVM, SDC2, Linux LVM, and SDA1, Linux LVM. Only here, the SDC1 is with normal Linux, is the boot partition, 700 megabytes by roundabout. So, and now the detailed output. You see here the dev mapper, dev mapper, dev mapper. So here we see deb volume group, volume group, volume group. Yeah. Again, this is the physical volume, and this is the volume group. The swap, this is the logical volume, logical volume, logical volume. Swap, 300 megabyte, home, root. So this is the output from sudo fdisk -l. So you can recheck this. So you know, one disk is only 3 gigabytes. So that big 6.8 gigabyte root disk would not be possible with one of the 3 small disks. But with LVM, we get a big volume group and can use all the space. So, okay, now system tools, system monitor. System, Debian13, kernel, and so on, available disk space. Also here, 4.2 disk space free wouldn't be possible if we only used the single disk. LVM make it possible. So, and here we see now, so SDC, the boot, 15% used, and the home logical volume is this one, 0% used, and the root logical volume, 62% used. And the swap is not shown here, but in resources you see the swap here, 300 megabyte. So swap is also the last logical volume. So this is why we don't see the last logical volume here, but only the root and home. Okay. So I hope this was well explained in detail, and I think there should be multi-disk usage analyzer. We can use this. Here you see the disk usage analyzer, 9 gigabyte, the whole capacity, and this one, but I don't want to do more about this. And then disk image mounter. Okay, this is this one. This is what you can use in Mate desktop. Kaya. Now we have here the DVD, the floppy disk, and here's the file system. Okay, this is a file system, root file system, and okay, no. Now what I have done, bookmarks. Okay, places, here's computer. So now here we see, okay, here, this is file system, the DVD is a floppy. And here you see 3 disks. These are the 3 disks. 3 disks we have can't mount. You see, he's showing the real disks, but we can't access them because they are binded together, concatenated in the volume group, LVM group. Okay, so I think let's check something out. Sudo apt install gnome-disk utility. We install the gnome disk utility from the DVD. I don't have gparted in this case. I had to insert the mirror before, and let's check out. Accessories here, GNOME disks. So also this is interesting in graphical view. Here you see the real disks. Again, qemu hard disk. In real would be shown as a real hard disk. This is this, and here you see these two ones are the same. The whole space is used as LVM physical volume, PV. And here you see the boot partition, and here the LVM physical volume. Yeah. So, and then the CD-ROM, and here now block device, block device, block device. These are the specific partitions on the physical volume on the groups. Here's the swap, 300. Here's home, home logical volume home, and here is the root logical volume. And interesting is also here's the logical volume name, and here's the volume group name. And you find this under the root file system under the dev devices folder. Dev, volume group name, logical volume name. Okay. So just showed this in the graphical way. I think this was interesting. And now you see what you can do with LVM. This was only the first step. There are more possibilities. For example, I can show you how to resize and extend the logical volumes. Yeah, and for example, I could change the disk size, the real disk size, from the qemu, qemu2 disk, and then I could extend the physical volume and the volume group and the logical volumes. But for today, that's it. Yeah, stay tuned. Subscribe on the channel, thumb up, and we will make more things about this in the future. So, and I will improve the way I create the videos and explain stuff. This was already very, very spontaneous. And I hope I will make it much more professional in 1 or 2 years. Stay tuned. So, and I forgot, I wanted to show you also not only the F output on the F disk, but the sudo blkit output and the lsblk output. And you will see here dev mapper, volume group and logical volume home, volume group, logical volume root, logical volume swap. Here you see SDC, SDA, SDA, SDB, yeah, and SDB here. So you see the hard disk with LVM2 member. This is the physical volume. This has their own UUID, like all these partitions. LVM2 member, LVM2 member. Only the SDA1 is with extended 4, and the specific logical volume on the volume group has a separate specific UUID. Okay, so we have many UUIDs in this case, which is important for the etc fs pub. So, and this is the output from lsblk. You see SDA1, this is the boot partition, then the logical volume swap, and the home logical volume, and the root logical volume. The interesting is this is all on the first disk in this case. And here the SDB1 has the root volume, logical volume root, logical volume root. Okay, so this is the output. And I give you also the -f. Here you see the lsblk-f output with all the UUIDs, for example. The boot, the swap, the home, and then here is the root, the logical volumes for the root partition. So this is what you can get and see. And then I want to show you also, let's do the space, cat etc fs tab, and here's the fs tab, and here we see dev mapper root logical volume mounted on root slash the root mount point ext4, and then the ext4 boot partition mounted on /boot, and then dev mapper again here for home logical volume and swap level logical volume. Home logical volume is mounted on /home with x4, and the swap logical volume is not mounted but is used as swap. Okay, and 3-m is this one. So this was just the other stuff for more detailed output for those who are really interested in the details. So it's very interesting just to know this example, see the output and see the use case. For me it's the first time, so it's also very interesting. So and it's also interesting to give this to you so you can imagine how it works, how it is putting together, and how to try this by yourself and create this by yourself. Stay tuned, I will do more things and more videos about LVM and Debian.